All right, what's up, guys? In this video, we're going to go to multivariable calculus. It's going to be talking about mixed partial derivatives. So we're asked to verify that f of x or f sub xy is equal to f sub yx for the following functions. We're given this function f of x comma y is equal to e to the x plus y plus 3. And we just need to verify the following here. So remember that f sub xy, that's just going to be second partial f over partial x times partial y. And remember, that's just the partial with respect to x of the partial of f with respect to y. So you just kind of got to get used to these notations. And then similarly, f sub yx, that's just going to be second partial f over partial y times partial x, and then that's just equal to the partial with respect to y of the partial of f with respect to x. So you just got to know the notations, and you'll be fine. So the first thing that we need to do is to go ahead and compute our first partial derivatives. So we need the partial of f with respect to x. Well, that's just the partial with respect to x for our function, which is e to the x plus y plus 3. And the derivative for that is just e to the x plus y plus 3, obviously. And we know that already, right? All right, so same thing. We'll have the partial of f with respect to y. And again, that's just the partial with respect to y for our function e to the x plus y plus 3. And again, that's also e to the x plus y plus 3. And remember, this is just chain rule, basically. So f sub xy, which we know is the second partial f over partial x times partial, times partial y, that's just equal to the partial with respect to x of the partial of f with respect to y. Now, remember that the partial of f with respect to y was e to the x plus y plus 3. So that means that f sub xy, which is going to be the partial with respect to x of the partial of f with respect to y, will also end up being e to the x plus y plus 3. So we validated that first one. Now we need to do it for the second one. So we need f sub yx. And again, f sub yx is just second partial f all over partial y times partial x. And again, that's just the partial with respect to y of the partial of f with respect to x. Now, the partial of f with respect to x, if we go up here, was e to the x plus y plus 3. So if we take the partial with respect to y of the partial of f with respect to x, that's also e to the x plus y plus 3. So as you can see here, we have in fact verified that f sub xy is in fact equal to f sub yx. So we verified it, basically. There's really no right or wrong answer to this. We were just doing some verification. So we've verified that the left-hand side is in fact equal to the right-hand side, or f sub xy is equal to f sub yx. So it's verified, basically. And that is how you verify it. That's your answer. All right, so if you're not familiar with the partial derivative notation, this will not be a fun exercise. So make sure you get comfortable with the partial derivative notation. If you do that, you'll be good to go. All right, so that's your answer. Let me know if you guys got any questions about it. I'll see you guys next time.